Hello everyone, our today's session covers a very important acid and our good friend sulfuric 6 acid. Now it is manufactured by the contact process. What are the raw materials required to manufacture sulfuric 6 acid? We have SO2, sulfur 4 oxide and air. When I talk of air in this whole session, I will be referring to which part of air? Oxygen. Okay, so before preparing sulfuric 6 acid, we need to know why are we preparing sulfuric 6 acid? What are the uses of H2SO4? So sulfuric 6 acid has a number of uses, but the ones that we can remember, we need 2 or 3. So the first one is manufacture of soapless detergents, that we will look at it in organic chemistry too. Also we have cleaning metal surfaces, a process known as pickling. It is used in manufacture of lead acid accumulators in car batteries. It is also used in manufacture of ammonium fertilizers. Which ammonium fertilizer? Ammonium sulfate. Okay. So these are the uses: cleaning metal surfaces, a process known as pickling, manufacture of dyes and paints, sulfate fertilizers, ammonium sulfate, electrolyte in lead acid accumulators. Now since we have known the uses of H2SO4, why we are preparing it, we go to the theoretical part where we actually prepare it, after which we will look at the flow chart. So what are we say the raw materials are SO2 and air. Which part of air? Oxygen. Now you can't use the raw materials just like that. The first step is purification. You need to purify the reactants. Why are we purifying the reactants? Why don't we just let them react? Because as you will see, as we will go further in the process of manufacturing, there will be a catalyst that is used. What is a catalyst? A substance that speeds up the rate of reaction. So if there are any impurities such as dust, arsenic compounds and moisture, that will poison the catalyst. We don't want that. We don't want the catalyst to be poisoned. That will make the process uneconomical. So we purify. How do we purify? We pass the reactants, which is SO2 and air, through filters or electrostatic precipitation to remove dust and arsenic compounds. So our step 1 is purification. Okay, now that is step 1 in the process. But before purification, we are needing SO2. Where is the SO2 coming from? We either heat sulfur in air to form SO2, or we use a metal sulfide such as lead sulfide or zinc sulfide. We heat it in air also to produce SO2. So we can either use sulfur plus oxygen to form SO2, or lead sulfide, a metal sulfide, we heat it in oxygen to form sulfur 4 oxide. So this is where we can get sulfur 4 oxide from. Air is just air, but sulfur 4 oxide, we produce it through 2 different ways: either heat sulfur or heat sulfide, a metal sulfide. Now after production of SO2 and after purification, what do we do to the gases? We dry the gas. Why are we drying the gas? To remove any moisture. Moisture is part of the impurities that may also poison the catalyst. So now we have pure sulfur 4 oxide and air. What are we doing to the pure sulfur 4 oxide and air? We are taking them to the part where you heat them, the heat exchanger. The heat exchanger. Now there are conditions that are present in the heat exchanger. That is temperature of 450 degrees, 450 to 500 degrees Celsius, and pressure of 2 to 3 atmospheres. Now if you have an issue remembering, this is 450 to 500. So temperature of 450 to 500 and pressure of 2 to 3 atmospheres. The higher temperature times the lower pressure gives you 1000. So that's how you can remember it. Now, what is the role of the heat exchanger? 1, it sustains the reaction temperature. It gives the reaction its temperature, the 450 degrees Celsius required to maintain the reaction. Okay, it cools the outgoing products. Now what are the outgoing products? What happens? What are the outgoing products? It is still SO2 and air. SO2 and air came into the heat exchanger, they got heated, and now they are being cooled before they leave the heat exchanger. Why are they being cooled? to prevent further decomposition of SO2 and air. If you heat the gases to provide enough energy and temperature for the reaction, if you do not cool them, excess heating will occur, which will lead to decomposition. Also, it provides the reactants with enough energy to react. Okay? Now, after you have heated the gas, you have taken them through the heat exchanger, what do you do to the gases? Your catalytic oxidation is what occurs. You carry out catalytic oxidation. Sulfur oxide gas is heated with air. Now, which part of air are we talking about again? Oxygen. Sulfur oxide is heated with oxygen to form sulfur 6 oxide. Okay? So, SO2 is heated with oxygen to form sulfur 6 oxide, SO3. Sulfur 6 will be sulfur valency 6 and oxygen valency 2. If you cross the 2, this will be S2O6 and you 1, 3, so SO3. So that is where sulfur 6 oxide is coming from. Okay? Now, what are the catalysts that can be used in this reaction, in the catalytic oxidation? A very important question. The catalyst used, vanadium 5 oxide. Or instead of vanadium 5 oxide, you can use platinized asbestos. Okay? Now, another important question is, vanadium 5 oxide is written as V2O5, or the full form vanadium 5 oxide. Another catalyst that can be used is platinized asbestos, vanadium 5 oxide or platinized asbestos. Now they can ask you, why is vanadium 5 oxide the preferable catalyst? One, it is cheap, so it makes the process economical, and two, it is not easily poisoned by the catalyst. If not all purification occurs here, if some dust, arsenic compounds and moisture is still left even after the purification, vanadium 5 oxide is less susceptible to impurities. Okay? After the catalytic oxidation, you have now sulfur 6 oxide. Now the SO2 has been oxidized by oxygen to form SO3. Now sulfur 6 oxide is what is going into the absorption chamber. What is happening in the absorption chamber? Now what happens in the contact process is that sulfuric 6 acid is used to manufacture more sulfuric 6 acid. Okay, so SO3 is dissolved in sulfuric 6 acid. This H2SO4 that we are using here is used to manufacture more sulfuric 6 acid. So SO3 will be dissolved in H2SO4 to form a viscous liquid called oleum. What is the formula of oleum? H2SO4. Okay. Now, an important question here asked, which I have written down here, is why is SO3 not dissolved in water? Why didn't we take SO3, dissolve it in water to form H2SO4? Why not? Because as we saw in SO2, in the video of SO2, SO2 will react with water to form H2SO3, sulfuric 4 acid. So why is sulfur 6 oxide not dissolved in water to form sulfuric 6 acid? Because the explanation for this is the reaction of SO3 with water is highly exothermic, means that it gives out a lot of heat that will lead to vaporization of the moisture. Now SO3 will cause acidity. So acidity in the moisture. So the highly exothermic reaction will lead to vaporization of the moisture, and that will cause formation of acidic rain. Acidic rain, now it leads to iron sheaths rusting and loss of soil pH, so much, and others. So that is the reason. So the reaction between SO3 and moisture is highly exothermic. So it leads to vaporization. The heat causes vaporization of the water. Okay, which will lead to formation of acid droplets in rain. Now, after the dilution, after oleum has been formed, H2SO4, after the absorption, we go to the final step, which is dilution. This is step 7. So all in all, there are 7 steps. 1, 2, 3, 4, catalytic oxidation 5, absorption 6, and dilution 7. So oleum is now dissolved in water. What do you mean by dilution? Dilution means addition of water. When you are diluting anything, you are adding water. So oleum added to water, what is formed? 2 moles of sulfuric 6 acid. Okay, so you used sulfuric 6 acid here, dissolved SO3 in the H2SO4 to form oleum. You then diluted oleum with water to form 2 moles of sulfuric 6 acid. So 1 mole of H2SO4 is forming 2 moles of H2SO4. So this is why I say H2SO4 is being used to manufacture more H2SO4. Okay, now let's look at the flow chart after this. So let's dive into the flow chart, which will help us remember what we already did and refresh with some questions. So we have 7 steps, as you can see. This is step number 1, step number 2, purification, drying, heat exchanger, catalytic chamber, absorption tower, and dilution. So production of SO2, we said we can either heat sulfur with oxygen to form sulfur 4 oxide, or metal sulfide with oxygen to form sulfur 4 oxide. So in this case, we just heated sulfur in oxygen to form sulfur 4 oxide. Now, what is P? Can anyone say what P is? Just in your memory. We were saying sulfur 4 oxide, the 2 raw materials are sulfur 4 oxide plus air, right? So if we already have sulfur 4 oxide, what is P? P is air. And which part of air exactly? Oxygen. So production of SO2, and then we go to purification. Purification, what is the function of purifiers? Remove dust particles and arsenic compounds. Remove impurities, in short, impurities. Filtration or electrostatic precipitation. We go to step number 3, drying tower. What is the question mark asking you? Which drying agent is used? Which drying agent is used here? It is without a doubt concentrated sulfuric 6 acid. That is the drying agent used to dry SO2 and air in the drying tower, to remove moisture, to prevent any poisoning of the catalyst. Now, after the drying tower, we go to the heat exchanger, which has some conditions. If we can remember, what was the temperature for the heat exchanger? Anyone? 450 to 500 degrees. And what was the pressure? 2 to 3 atmospheres. This is for the heat exchanger, not for the aero, but for the heat exchanger here. So after the heat exchanger, the SO2 and air have been heated, and they are now going for the catalytic oxidation. What is happening in the catalytic oxidation? SO2 is reacting with the oxygen part of air to form SO3. 2 and 2. And what is the catalyst used in catalytic oxidation? We said either vanadium 5 oxide or platinized asbestos. Why is vanadium 5 oxide used? Because it is cheap and less susceptible to impurities, so less poison if any impurities are present. After the catalytic oxidation, what is going back to the heat exchanger? What is Q? I'll give you 3 seconds to figure out what Q is, because from the heat exchanger we are going to the absorption tower. So what is Q? Q is sulfur 6 oxide. So Q is SO3. Sulfur 6 oxide going back to the heat exchanger. Now we say the heat exchanger has various functions. Maintain the reaction temperature. It also has a function of cooling the sulfur 6 oxide, the outgoing gas. Which gas is outgoing to the absorption tower? Sulfur 6 oxide. So sulfur 6 oxide going to the absorption tower. Now what is A? So we said in the absorption tower, what are we dissolving? The sulfur 6 oxide that has come from the catalytic oxidation going to the heat exchanger. It is cooled. This is cool SO3. Okay, I mean this is hot SO3. Sorry, this is hot SO3 going from the heat catalytic oxidation to the heat exchanger. Then this is cool SO3. It has been cooled in the heat exchanger to prevent its decomposition back to SO2 and oxygen, because here the reaction is reversible. So the cool SO3, then we say in the absorption tower, it is dissolved in a liquid. Which liquid was that? We said it isn't dissolved in water. Why? Because the reaction is highly exothermic. It will lead to vaporization and formation of acid droplets in air. Now, which liquid are we using to absorb the to absorb the SO3? Concentrated H2SO4. The part where we said H2SO4 is used to make more H2SO4, we dissolve SO3 in H2SO4 to form oleum. Who remembers how oleum is written? Oleum is H2SO4. That's oleum. From the absorption tower now, oleum being a viscous liquid is going into the dilution tower. So in the dilution, what happens in dilution? What is B? Obviously, B is water. In dilution, in any dilution, you are adding water. So oleum is dissolved in water to form, what is X? Oleum dissolved in water or diluted by water to form H2SO4, 2 moles liquid. This is 98% H2SO4. That is why it's a liquid, it's concentrated. So oleum H2SO7 plus water to form conc H2SO4. So this is the flow chart for manufacturing H2SO4 by the contact process. If any questions, feel free to ask in the comment section. If you like my channel, show some love, like, share and subscribe. Thank you so much. Keep watching.